Assalamualaikum everyone, I'm Arslan with my new video. In this video we'll discuss about three-dimensional trigonometry. Now on the screen, as you can see, the three-dimensional questions will look like this, which I have put here. This VR line is vertical line and PQRS is a horizontal plane, right? And always remember that vertical and horizontal will always make a 90-degree angle. Okay, so this is something new in this trigonometry topic, in which we are discussing three-dimensional. Okay, so we are going to look at the pictures in which how we manage the three dimensions, right? Three-dimensional concept is little bit different from our normal two-dimensional concept, right? So let's see something about three dimensions. I have made some videos, like question number 1 was having a pyramid shape, right? So I have drawn it here in three dimensions. You can see that this and our question is almost same. There is a rectangular base, and then there is a vertical line VR, and then there are some faces, right? So if you look at here in this diagram, so you can see this is our VR line, which is making a 90-degree angle with the plane, right? Alright, so you can now visualize how things work in three dimension. Okay, always remember, whenever we have a 3D diagram in which we have a vertical plane and a horizontal plane, they will always make a 90-degree. You can see the 90-degree here formed. Okay, I can show you from different angles. So it is the concept of height. You can see that this line is representing the length, this line is representing the width, and this red line going up at the 90-degree is representing the concept of height, right? This is the line. Okay, so that's how we deal trigonometry. Now you can see that we are having many right angle triangles formed in this one diagram. Like if I can draw it here with my mouse pointer, this is also a right angle triangle, and then we have a right angle triangle with this diagonal line and this line where I'm moving my mouse. Okay, 1, 2 and 3. These three lines are also making a 90-degree angle, so they are making a triangle, right triangle. Okay, so this is the concept of 3D. I have drawn it in 3D plane so that you can better understand this concept, right? So let's go back to the question. Where is my question? Question is here. Okay, so this is something we need to solve. In the figure, a pyramid has with a rectangular base. You can see that rectangular base is here. Okay, PQRS is a rectangular. It is always drawn with shaded color, right? And vertex V means it is vertically above, means making a 90-degree angle at R. You can see that this 90-degree here as well. Alright. So what we need to find, lengths are given, lengths are mentioned on the diagram as well. We have PQ 12 centimeter, QR 5 centimeter, and VR 3 centimeter, and we need to find VQR. Now if you look at VQR, this is V, this is Q, and this is R. So let's make it a separate triangle. V is vertically above R, right? At R we have a 90-degree angle because these are vertical and horizontal intersection, and this is point Q. You see that I have taken out this VQR triangle here, right? This triangle is taken out. Now the length QR is given equal to 5 centimeter and VR is given equal to 3 centimeter, and we need to find angle VQR, and angle will be formed here. Now you can easily understand how can we find it. This is our part 1. Alright, so any guesses? I'm going to use trigonometric ratio, and this side is representing the opposite and 5 centimeters representing the adjacent. So everybody should understand that we are applying tangent VQR angle, which is required angle, and it is equal to opposite over adjacent means 3 over 5, and then VQR angle must be equal to tangent inverse 3 over 5, and then we'll use the calculator to find the final answer. It's very simple question if you understand the concept of 3 dimension, right? Mostly we will be using Pythagoras theorem or trigonometric ratios mostly. So the answer is 30.96, means it will be approximately 31 degree. 30.96 shown on calculator, right? But in Cambridge we must give our answer correct to one decimal place and for angles, and when it will be rounded to one decimal place, it will become 31 degree approximately, right? So that's how we'll be solving the first part. Similarly, the second part, VPR, let me erase the extra lines. Okay, VPR angle, where this angle is formed, V, this is V, this is P, and this is R. Now you see that we need to draw the diagonal of the rectangular base. I need to draw this diagonal, right? I can show it on the 3 dimension, you can better understand this. Here is this line, you can see, and this is the diagonal line. Let me change the angle. Okay, so this is that vertical height, this line is representing the vertical height, this is the diagonal of the rectangle, and this is the slant height of the pyramid, right? So you can see these 3 points, this one, and this one, are making 90 degree right angle triangle, right? At 90 degrees formed at the diagonal and the vertical line. Okay, so let's get back to the question. Same concept is here. VRP is a right angle triangle. Let's draw it separately on our page. I am drawing it in a standard way. Now V is above R and it has the same length, 3. Okay, and similarly P is here, and we need to find this P angle, but for this I need to have one more side, and I can find this PR side. If you can look at the diagram, I can find this PR just by considering this triangle, and the name of the triangle is PQR. Now PQR is also a right angle triangle because in the base we have a rectangle, and rectangle has the corner angles of 90 degree. So I'm taking triangle PQR before solving my actual question. PQ is 12 centimeter, QR is 5 centimeter, and I need to find the length of PR, and here we have a 90 degree angle. So first in triangle PQR, this is our second part. In triangle PQR, we are applying Pythagoras theorem. P R square equals to 12 square plus 5 square. So you can solve it orally. PR square is equal to 144 plus 25 equals to 169, and then you have to take the square root for finding the answer of PR, and PR will be 13. You see that for finding the extra actual value we need to find something extra. Now PR is 13, and I can easily find this angle VPR angle. Now after this part I am considering the triangle PRV. I am applying tangent. It's tangent VPR, which is our required angle, angle is at RP equals to 3 over 13, and again we'll take tan inverse. VPR is equal to tangent inverse 3 over 13, and then you'll use your calculator. Shift tan inverse 3 over 13 will give you, make sure your calculator is in degree, 12.99, which will be approximately equal to 13 degree, right? So that's how we'll be solving our three-dimensional questions. You can see only understanding of diagram is important. Working is simple, only we have to apply either the Pythagoras theorem or the trigonometric ratios, right? So that's how we'll be solving our three-dimensional question. There will be some more examples. Okay, so this is our new question. A rectangular block of sugar has a horizontal base EFGH. The corners C and D are vertically above E and H respectively. It is given that DH is 4 cm, GH is 6 cm, and FG is 8 cm. You can see on the diagram, okay. C and D vertically above means they are making 90-degree angle, and of course from the three-dimensional figure we can see that I have drawn a cube. You can consider it as a cuboid as well. So you see all the corners are making a 90-degree angle, right? So these are the 90-degree angles. Here we have a 90-degree angle. Whenever a horizontal and a vertical line are meeting, they are making a 90-degree angle, okay. Okay, so first thing we need to find is DGH angle, right? Angle DGH is something you can easily find on the diagram. D, and this is G, and this is H. So you can see it's a right angle triangle, easily understandable by us. So let's draw this triangle separately on our page to have a perfect calculations. It is D, which is vertically above H. It was given, right? And this is G. We have the length 6 cm is 8G, and DH is 4 cm, right? So diagram is all there. Now we have to find angle DGH, which is here. I need to find this angle, so you can easily understand. Again I'm telling you it's tangent, right? So I told you that we are mostly using the trigonometric ratios or Pythagoras theorem. So part 1 is very simple to solve. It is tangent x equals to 4 over 6, and one step solution is x is equal to tan inverse 4 over 6, and then you will use your calculator to find the final answer. X is equal to tan inverse 4 over 6 will give you 33.69, that is shown on the calculator, 33.69, which will be later rounded off to 33.7, right? So this is our final answer, and this is the answer of DGH angle. So that was easier. In second part we need to find HF. Now HF is this diagonal line. I think I have to use another color. This is HF. Now it is included in the triangle AGF because it's a rectangular base cuboid. So what we have to do, we have to make a separate triangle. The name of the triangle is F, H and G, because corner of a rectangle is at G, so it is making a 90-degree angle. So HG is 6 cm and GF is 8 cm. It was given, and we need to find HF length, which is here. So you can see it's a simple Pythagoras theorem. So it is HF square hf square is equal to 8 square plus 6 square. So it is hf square equals to 64 plus 36 equals to 100, and when you take square root of this value hf to obtain hf answer, then hf will become 10 centimeter, right? So you see, questions are very simple. And then we need to find the angle of elevation of D from F. Now D from F will be somewhere here, right? It is starting from D and going towards F, and you see with this diagonal line it is making a 90-degree triangle, right? So let's draw it separately. This is the third part. This time we are taking triangle DGF. Wait a minute, let me make a correct diagram. It's a right angle triangle. Here we have a 90-degree angle, and this is D, this is H, this is D, this is H, and this is F, right? And HF we have just found, it is 10 centimeter, and DH is given, it is 4 centimeter. And we need to find the angle of elevation of D from F, means we have to make this angle, and we have to find the value of angle of elevation is at the ground level, and it is always equal to depression angle. In previous lectures I told you about the depression and the elevation angles. Both are alternative angle of each other, so they are always equal, right? Now question is again very simple, again a tangent ratio, tangent x, which I have taken as angle of elevation, equals to 4 over 10, and then you'll take tan inverse of the value, tan inverse 4 over 10, and then you'll use your calculator, shift tan inverse and 4 over 10. The answer is 21.8. X is equal to 21.80, so it will be our final answer. And you see that that's how we'll be solving three-dimensional questions. Okay, I hope concept is clear by now and you can easily solve these questions. Okay, so here is the last question, and it is OABCD is a pyramid. The square base ABCD has side of length 20 centimeter and lies in a horizontal plane. M is the point of intersection of the diagonals of the base, and O is vertically above M, right? So you can see it is in 3 dimension, and this dotted line OM is making a 90-degree angle with AC and DB, right? To make it clear, let's have a look at this pyramid. You can see the vertical height is always coming from the vertex and cutting the base at the center, right? So you see that if I draw a line from this point to this, it will be making a 90-degree angle, right? Let's draw this line. Let's see how does it look. I am making with this and this center point. So you see that it will be a right angle triangle. Okay, so you see that this is the line, and this is the height, and this is the hypotenuse. So it is adjacent, opposite, and hypotenuse. So it will be a right angle triangle, right? So this is the main concept in this question, that you must understand where we have a 90-degree angle, right? So this pyramid is drawn in 2D. We cannot rotate it, but we can understand that OM is making a 90-degree angle with AC line, right? And similarly OM is also making a 90-degree angle with DB line, right? Okay, given that OA is 32 centimeter, the length of OA is given. OA is this diagonal line, the side of the pyramid, you can say, and we need to find the length of AM. AM is required. AM we can easily find by taking triangle ABC. ABC triangle. How do we use it? So let's look at the solution. This is A, this is B, and this is C, right? So I'm going to make a separate diagram ABC. I'm solving first part. It's again a right angle triangle. Why it is a right angle triangle? Let me erase it. It's not looking like a right angle. So let's make a right angle triangle. The opposite side, the adjacent side, and the hypotenuse. Here we have a 90-degree angle. Now the labeling is very important. A, this is B, and this is C, right? AB is 20 centimeter. It is given in the question. BC is also 20, and it was mentioned that base is a square base, so it means that at B we have a 90-degree angle, right? It doesn't look like 90 here in the diagram, but it is a 90-degree, right? And I need to find the length AC. AM I'll be calculating from the answer of AC, right? So it's a simple Pythagoras theorem. It's AC square is equal to 20 square plus 20 square. So it will be 400 plus 400 is 800. And then I'll take a square root of 800. And mostly these questions are in P2, so you can use your calculator, otherwise you'll give your answer in square root form. It's 28.28 centimeter, but I need to find AM only. M is the midpoint, right? Suppose I'm drawing the midpoint M here. So what I have to do to find AM, I just have to make this 28.28 half to get my final answer. AM is equal to the length of AC divided by 2, so it will be 14.14 centimeter, right? So that's how we'll be solving the first part. And then the height of the pyramid is OM. For the second part, it's the B part, we are taking new triangle, and this time O, M and A, because I have the length of AM. This is O, this is M, and this is A. OM is unknown, we need to find it. It's a 90-degree triangle. AM we have calculated as 14.14, and AO or OA is given equal to 32. It was given in the question, right? This is 32, so I have taken it from here. Again I need to find OM, and it's a simple Pythagoras part. 32 square equals to OM square, which is unknown, plus 14.14 square. So OM can be written as OM square equals to 32 square minus 14.14 square, and then use your calculator and take a square root to find the answer of OM. So OM is square root of 32 square minus 14.14 square, and the answer is 28.71 centimeter, right? And then I need to find OAM angle. OAM angle is here. It's easier. I need to find this angle, so this is C part. I'm using the same triangle. It is the C part. In C part you can see 14.14 was calculated, and this 32 is calculated. Even OM is also there, so we can use any trigonometric ratio, but right now I'm using cos. So it is cos x equals to 14.14 divided by 32, and then you'll take cos inverse. X is equal to cos inverse 14.14 over 32. Use your calculator to find the final answer. All of you must do the calculation with the working on the screen so that you may verify the answers. I might be making some mistake. If there is any mistake, you can point out in the comments. So x is equal to 63.77 or 78. So final answer will be, I am finding OAM angle. OAM is equal to 63.8 degree. This is our final answer, right? So that's how we apply the trigonometry in 3 dimensions. I hope you'll make practice of these questions, and if something is not clear, please mention in the question. I'll make a special video for you to clear all the questions, right? Thank you very much.